Hello guys, today I'll start to talk about forces, everything related to force in our syllabus, like types of forces, like Hooke's laws, like Newton's first law and second law and third law. So let's start our session. Stretching materials. Actually, when the force are applied to the material, the size and shape for this material will change. Like what? If we have sling spring, this sling spring as you see in front of you, if we start to affect with the force on this sling spring, actually the size and shape for this spring will change. And by increasing the force, we have more extension for this spring. Actually, we want to know the relation or to mention and determine the relation between the applied force and the extension for the material. We want to know if we have directly proportional or inversely proportional. So we have to do an experiment to mention this relation. As you see in front of you, we have spring and more than one mass. We want to add the mass so we can calculate the extension for the spring. First, we have to measure or to calculate and record the original length for the spring. So I'll start to put the spring first here. As you see in front of you, we want to mention and determine the original length for this spring. So I have to move the marker to the bottom of the spring to mention its length. So here, this will be the original length, which is 20 centimeter. Actually, I'll add or I write these results in this table. We have mass, force, spring length in centimeter, and extension in centimeter. The mass from 0 and 10, and I'll add 20, and then I'll add 30 grams. And I'll change the mass into force. How can? We said before, W equal M times G. So you have to multiply the mass times 9.8, which is the gravity. But take care, you have to convert between gram to kilogram, then multiply by 9.8. For example, here we have mass equal 10 gram. I have to divide it by 1000 to change it from gram to kilogram, then multiply by 9.8 to obtain the force in Newton. And then I'll start to calculate the extension as you will see with me. After that, I'll start to add the first mass, which is 10 grams as you see. So what will happen to the extension? It will be more. I want to get or determine the second length or the new length for the spring. So as I said before, I'll start to move the marker to record the length down as you see. So this will be the new length, which is 25 centimeter as you see. I write it here below the spring length as you see. Then I want to add another mass, which is 20 grams. So what will happen? We have more length, increase in the length of the spring. To mention its length or new length, I have to move the marker down to obtain the new length, which is 30 centimeter. So I write here 30 centimeter. The same thing for the last one, 30 grams. So what will happen? It will be more stretched. I'll start to move the marker down. The new length will be 35 centimeter. I write here 35 centimeter. Then we want to write or calculate the extension. We know the extension. I have to subtract the stretched length minus unstretched length. The stretched length, ya shabab, 25 or 30 or 35. But unstretched length, which is the original length, is 20. Right? So I'll start to subtract 25 minus 20, then 30 minus 20, then 35 minus 20. So here we have 5 for the first one. And then we have 10, because 30 minus 20, it will be 10. And the last one, 35 minus 20 will be what? Will be 15. So take care about the relation between force and extension. By increasing the force, the extension will increase. So we have directly proportional between force and extension, and this will be the Hooke's law, as you will know about it now. So here we have 15. So that's it. So this is the experiment as we said. After that, I'll start to draw graph relation between extension and force. If we represent or draw a graph, the relation between extension on the y-axis here and the force on the x-axis, the shape of the graph will be like this. But if we represent the force on the y-axis and the extension in meter, for example, on the x-axis, this will be the shape of the graph. I'll talk about the elastic limit and limit of proportionality, but first, let me tell you the meaning of deformation. Actually, the deformation, if we have a spring and we start to affect with the force on the spring, so the size and shape of the spring will change. This is the meaning of deformation. After that, we have two main types of deformation. We have elastic deformation and we have plastic deformation. Actually, if we start to affect with the force on the spring, and then when we remove this force from the spring returned back to its original shape, so this means that we have elastic deformation. Elastic deformation. But if the spring does not return back to the original shape, so we have plastic deformation. So now in this spring, you can tell me, now, is this spring elastic or plastic deformation, as you see in front of you? Actually, it does not return back to the original length because we have gaps between the coils. So now we have, yes, plastic deformation. So here we have elastic deformation, as you see, and also plastic deformation, the difference between them, as I said. Okay, let's start to talk about the Hooke's law. Hooke's law states that the extension of the spring is directly proportional to the stretching force up to the limit of proportionality. One more time, the extension of the spring is directly proportional to the stretching force up to the limit of proportionality. But let's talk about the limit of proportionality. Before that, we have to write the mathematical formula for Hooke's law. Actually, as you see in front of you, we have F equal K times X. So we have force, spring constant, and extension. Why? Because we have here F directly proportional to the extension. So this means that by increasing the force, the extension will increase. But take care, we have limit of proportionality. I'll talk about it now. Now I can rewrite the equation to be F equal spring constant times extension. F equal K times X. So now I can write F, as I said, equal K times X. And I can put it in the triangle, as you see in front of you. I write here F equal K times X. Actually, F, which is the force, K, which is the spring constant, and X will be the extension. And I can calculate the extension, just subtract the stretched length minus the original length. This will be the extension. So I can get the K, which is the spring constant, from here. K will be equal F over X. So this means that the spring constant is the force per unit extension. This is the definition according to the new syllabus. Force per unit extension. And what about its unit? Actually, its unit depends on the unit of force and the unit of the extension. For example, if the force in Newton and extension in meter, so the K will measure in meter or Newton per meter. So it will be Newton per meter. If the extension is centimeter, so the K will measure in Newton per centimeter. So according to the unit of the extension, I can mention the unit for K, which is the spring constant, as you see. Okay, let's talk about the limit of proportionality. Actually here, ya shabab, if we draw this graph, we have relation between force and extension. As you see, this region is linear region. This means that by increasing the force, the extension will increase. But take care about this point, which is the limit of proportionality. Actually, beyond this limit, K or F will not be directly proportional to the X, which is the extension, till this point. So this means that the limit of proportionality, as you see, the point beyond at which the load and extension are no longer proportional. K or F will not be directly proportional with the extension beyond the limit of proportionality. Beyond this point in the graph, beyond this point in the graph, as you see. Actually, after this point, we have elastic limit. Elastic limit. Actually, beyond the elastic limit, we have plastic deformation. This means that when we remove the force, the spring or the material will not return back to the original shape. So this will be the elastic limit. So what about the elastic limit? Actually, the elastic limit, the point at which the spring will not return back to its original shape after being stretched, as you see. What about the spring constant? We said it's the force per unit extension, as we said. So here we have two graphs. If we have force on the y-axis and the extension in meter, for example, on the x-axis, so this will be the shape of the graph. But take care about that if we inverse x and y. Here we have extension on the y-axis and here we have force on the x-axis, so this will be the shape of the graph. So take care about that. Take care about that. Okay. As you see in front of you, we have plastic deformation at which spring? Actually on this spring, as you see. We have plastic deformation because we remove the force, but the spring does not return back to its original shape. So here we have plastic deformation, as you see in front of you. What about the force? Actually, the force is the push or pull that exert from one object on another. This will be the force. And the unit for force, Newton. So here, the force is defined as the push or pull that acts on an object due to the interaction with another object. Actually, the force can cause many things for the object. Can change the speed of the object. Speed up makes the object speed up or slows down. Can cause the change in the direction of motion of the object. And also can change the shape for the object. So here we have change in shape or change in speed and change in the direction and change in shape. It will be maybe stretch the object or compress the object. So we have increase or we have change in the shape of the object or the direction of the object or the speed of the object by using the force. So the force can cause that, can cause change in the speed, change in the direction, and also change in the shape. Let's talk about the types of forces. Actually, we have many types of force, ya shabab. The first force, which is the tension force, just one tension. So we have tension force. The tension is the force experienced by the object like rope or cable when pulled or hung, rotated or supported, as you see in front of you. Here we have the tension force. And take care about the force. We said force, vector quantity that has both magnitude and direction. Magnitude and direction. As you see, the tension toward each other. The two tension forces toward each other. So this will be the tension. The second thing about the normal contact force. What about the normal contact force? If we have an object like this, and I'll put it on the table. So actually we have two types of forces that affect on this object. We have downward force and upward force. The downward force, which is the weight for this object, and upward force, this upward force perpendicular to the surface, I can name it as normal or contact force. Normal or contact force. So one more time, the normal or contact force always perpendicular to the surface and work or affect upward. So this is what we said about the normal or contact force. After that, we have upthrust force. Actually, we can name it as buoyancy force. When the object in the fluid or inside the fluid, so we have upthrust force, upward. What about the fluids? Actually, you took it before. The fluids means liquid or gas. So when the object in the liquid or gas, it will be affected by the upthrust force. So this will be the upward buoyancy force acting on an object when it is in the fluid. As you see in front of you, here we have weight and here you have upthrust force and the object in water, as you see in front of you. After that, about the friction, this is a type of force. The friction acts opposite to the direction of motion. Friction of the object or the friction, it's a type of force that caused will be, or its direction will be in the opposite direction of motion, and its unit is Newton, like the types of force, any type of force. So here the friction is the force that opposes the motion of an object caused by contact, rubbing of two surfaces, and it always acts in opposite direction of motion. Actually, we can name the friction force by many names, like air resistance or drag force. When the object in fluid, so we can name the friction force as air resistance or drag force. Air resistance or drag force. And as I said, air resistance or drag force opposite to the direction of motion. Opposite to the direction of motion. So here we have a resistance called drag force. Okay, when the object moves on the air. Okay, and by the way, the friction makes the object or the surface increase in its temperature. So it has a thermal effect on the object due to the friction, because we have friction between two surfaces. This will increase the temperature. So here, the friction results in the energy loss due to the transfer of energy from kinetic to internal, means heat. Actually, after that, the force of the friction between two surfaces of the object increase the friction by increasing the roughness between the two surfaces and by increasing the weight of the object. If we have more weight for the object, this will increase or will get more friction force. After that, the resultant force. We talked it before. If we have more than one force affecting the object, so actually to mention F net or the resultant force, I have to mention the direction of each force. If the forces act in the same direction, so we can add them together, and the resultant force will be in the same direction of these forces. But if the forces act in opposite direction, to get the resultant force, we have to subtract these forces, and the resultant force will be in the direction of the greater force. For example, if we have the first object 5 Newton to the left, 5 Newton to the right, so what will be the resultant force? Actually, the resultant force will be 5 minus 5 equals 0. So now this object in equilibrium, balance. Okay, so this will be the resultant force. The second example, if we have two forces, 3 Newton to the right, 7 Newton to the right. If we want to calculate the F resultant, I have to add them together because they act in the same direction. So 3 plus 7 equal 10. And the resultant force will be to the right. The last one, I have two forces, 3 Newton to the right, 7 Newton to the left. So the F resultant, just subtract them, 7 minus 3 equal 4, in the direction of the greater one. So it will be 4 Newton to the left, as you see. Also, as we said about the parachutist, the parachutist here will be affected by two forces. One of them is the weight, acts downward, and the second one, air resistance, acts upward. In this case, we have two forces equal to each other, work in opposite directions. So this means that the parachutist move with a terminal velocity or constant velocity because these two forces equal to each other. And the same thing here about the mass. This mass remains at rest because we have tension works upward and weight, which is the direction of the weight, downward. These forces or two forces equal to each other, opposite direction. So this means that the mass remain at rest. Here we have worked example. Calculate the magnitude and direction of the resultant force in the diagram below. Actually, we have diagram here. We have three forces. We have 4 Newton, 8 Newton, and 14 Newton. Actually, we want to calculate the forces. Actually, we have to add these two forces with each other, 4 Newton plus 8 Newton, because they work in the same direction. It will be 12. So here we be 12 Newton. But here we have 14 Newton in the opposite direction. To get the F resultant, just subtract them. So F net, F resultant equal 14 minus 4 plus 8. So equal 2 Newton in the direction of the greater one, 2 Newton to the left. That's it. Here we have examiner tips and tricks. Actually, if he asked you to calculate the resultant force, don't write only value. You have to mention the direction. Yani, for example, the resultant force equal 10 to the right, 10 to the left, 10 in the north direction. So you have to write just value and direction. So this is the examiner tips and tricks, as I said. Force and motion. Actually, when an unbalanced or resultant force acts on the object, this will make the object, when the force affects on the object, this will make the object, this force affect the object, the force will make the object speed up or slow down or change in shape or change in direction, as we said. So here we have maybe the object speed up due to this force, maybe the object slow down, maybe the object could change its direction, as you see in front of you. And these are the examples. I'll talk about each one of them later. What about Newton's laws? Actually, we have Newton's first law and Newton's second law and Newton's third law. The first one, Newton's first law. If I put the pen here on the table and move out and then I return it back, the pen will still as it is, will be at rest. The pen will not change. Its direction will not move. Only if I didn't affect with the force on this pen. This is Newton's first law. So Newton's first law of motion, the object remain at rest, will remain at rest, or move with a constant velocity unless it is acted by an unbalanced force. I'll start with affect with a force on this object, so the object can move. But if I leave the object like this, the object will still at rest. The object will not move. But if I start to affect with a force on the object at this moment will start to move. This is related to Newton's first law. So here, Newton's first law, objects will remain at rest or move with a constant velocity unless acted by a resultant force or an unbalanced force. Second law of motion. Actually, this is the relation between acceleration and force. Acceleration and force. So here, if we have force and acceleration, we have directly proportional between the force and acceleration for the same object that has the same mass. So F directly proportional with the acceleration, or acceleration of the object is directly proportional to the force, and its direction will be in the same direction of its force. Its direction, yani direction of acceleration, will be in the same direction of the direction of force. So F directly proportional with A, so F equal mass times acceleration. So that will be the mathematical formula for Newton's second law. And I can put the Newton's second law in this triangle. Here we have F and M multiplied by A. So we can get any one of them. I can get F equal M times A from the triangle, and M equal F divided by A, and A equal F divided by M. Force measured in Newton, mass measured in G, kilogram, and acceleration meter per second square, or meter second negative 2. So this is related to Newton's second law. Here we have an example. A car salesman says that his best car has a mass of 900 kilogram and can accelerate from 0 to 27 meters per second in 3 seconds. Calculate A, the acceleration of the car in the first 3 seconds. B, the force required to produce this acceleration. So let's start to solve this question. Here we have the mass, which is 9 kilogram. Please, if you want to answer any problem in physics, first, don't hold the calculator first. No, you have to write the given first, and then take care about the convert. If you convert any unit to the other unit, take care about it, and then just choose the suitable rule or law, and then put the numbers, get the final answer and unit. That's it. So don't hold the calculator with your hand first. No. First, you have to write the given first with the suitable scales or units. So here we have 900 kilogram. So this will be M equal 900 kg kilogram. Okay. And he said accelerate from 0 to 27 meter per second square. So here you have U, which is 0, and V, which is 27 meter per second. Take care, there is no S for speed. No, it's not allowed in the updated syllabus. Only U and V. U is the final or the initial speed, and V is the final speed. And then we have time equal 3 seconds. So we want to mention or calculate the acceleration. Actually, we know the acceleration A equal V minus U divided by T. So here we have V, which is 27 minus 0 divided by time, which is 3. So we have 9 meter per second square. So this will be the acceleration. The force required. How can I get the force? Newton's second law. So we have F equal M times A. So equal M, which is 900, okay, times acceleration 9. So let's put it here. So we have 900 times 9. It will be 8,100 Newton. This will be the answer. Newton's third law. Actually, the Newton's third law, we have action and reaction. We have two forces equal to each other but opposite directions. So this will be the Newton's third law. For every action, there is an equal and opposite reaction. For every action, there is an equal and opposite reaction. So here, for example, we have many examples for the Newton's first or third law. Here we have two objects. If you have foot and the ground, as you see, here we have contact force between them. So the force on the foot from the ground here will be equal and opposite direction to this force, which is on the ground from your foot. So we have two forces equal to each other but opposite direction. Action force and reaction force, equal in magnitude but opposite in direction. This is the Newton's third law. It's very easy. After that, you know the planets, guys, that all the planets can revolve around the sun in a definite orbit. So these planets will not move toward the sun or away from the sun. Actually, why? Because we have two different forces affect on each planet, and these forces equal in magnitude but in opposite direction, so the planets can move in a fixed path or orbit. Actually, these forces are, the first one, centripetal force. Actually, the centripetal force acts toward the center of the circle. That will be the centripetal force toward the center of the circle. Okay? And also we have the second force, we can name it as centrifugal force, acts away from the center of the circle, away from the center of the circle. And by the way, we can mention the centripetal force, Fc equal M times V square over R. So here we have Fc, which is the centripetal force, equal mass times square root of the velocity divided by radius. Radius, which is the distance between the object and the center. For example, the moon and the earth. This will be R, which is the radius of the circle. Okay? So let's talk about this rule, ya shabab. Actually here, I want to mention the relation between Fc and M. Fc and M. Actually, to mention the relation between two quantities, as you know, you have to keep the rest constant. يعني ال V وال R must be constant. The velocity and radius must be constant. This means that force and mass, we have directly proportional between them. This means that by increasing the mass, the force will increase. Decreasing the mass, the force will decrease. So this is the relation between Fc and M. And take care, V and R in this case must be constant. So a greater mass requires a greater force, as I said. This is the first thing. The second thing, what about the relation between Fc and V? I have to keep what constant? I have to keep mass and radius constant. Actually, we have directly proportional between Fc, centripetal force, and a square of the velocity. This means that The faster the object requires greater force. Faster moving object requires greater force. Okay? After that, let's talk about the relation between R and Fc. Actually, we have inversely proportional between radius and centripetal force, but you have to keep M and V constant. So this means that smaller radius requires a greater force. Smaller radius requires a greater force when the M, mass, and velocity constant. Let me give you an example for that. If I asked you question, what happened if we increase the velocity of the object to double? What will happen to the centripetal force? Mass and radius kept constant. So the relation will be between V and Fc. So let me repeat it one more time. What will happen if we increase the velocity of the object to double? What will happen to Fc? And M and R will be constant. As you said, we have directly proportional between V and Fc. So this means that the force or Fc centripetal force increase. But I said speed or velocity increase to double. So you have 2 to the power of 2 will be 4. So this means that the force will increase by the factor 4. That's it. Thank you so much for watching a video and attending my session. See you inshallah in the next session. Thank you so much. Have a nice day.